In this example, we will antidifferentiate e to the x multiplied by cosine x. Now the form of our integrand here, an exponential times a cosine, this fits one of the standard forms from integration by parts. So we'll go ahead and apply integration by parts, and when it comes to choosing u and dv, either function could play the role of u or either function could play the role of the dv. I'm going to go ahead and let u be equal to e to the x and dv be the cosine x. Then v will be the antiderivative of cosine, which is sine, and du is e to the x. So integration by parts gives us that the integral of e to the x cosine x is equal to uv, so e to the x sine, minus the antiderivative of e to the x sine. And looking at our integrand, unfortunately the integration by parts did not give us a resulting integral that was easier to evaluate, about the same level of difficulty. And note this also fits the form of integration by parts. So let's just proceed with another integration by parts. And I'm going to go ahead and use the variables u and dv again, but hopefully from the organization of my work it's very clear at which step I'm applying which integration by parts. And it's key here that we remain consistent with our choices. Whatever role e to the x played in the first integration by parts, it needs to play that same exact role in the second integration by parts. Otherwise, we will just end up undoing our work from the previous step. So in this case, v is minus cosine, and du is e to the x. So the e to the x sine x carries down, and then we are subtracting away uv, so minus e to the x cosine x, so minus a minus makes it a plus. And then we are going to also have, well, let's see here, we have to be careful with our minuses. We have the minus sign, which is out front, then we have the minus sign from the v, and the minus sign that comes from integration by parts. So we have three minus signs, which gives us a net minus, and it'll be the integral of e to the x cosine x dx. And at this point, the observation to make is that we came back to the exact integral we started with. You know, this is all equal to the integral of e to the x cosine x dx. So in order to evaluate, what we'll do is just isolate the quantity that we want to solve for. I see it appearing on both sides, so let's take the term on the right and add it over to the left. So 2 times the integral of e to the x cosine x is e to the x multiplied by the quantity sine plus cosine. And lastly, let's just divide by 2. So the antiderivative that we are hoping to evaluate, e to the x cosine x, is going to be e to the x times sine plus cosine, all divided by 2. And because it is an indefinite integral, we need to make sure we remember that plus c. So note, this is a common technique when it comes to integration by parts, where you apply integration by parts some number of times, you come back to that integral you are trying to evaluate, and then you equate together those terms and you isolate them.